Hello, and today we are going to talk about the memory hierarchy in computers. Before we talk about the memory hierarchy, it's important to understand what memory is. So what is memory? Simply put, memory is a device used to store information that the computer can use. Without instructions, your computer would be worthless. The CPU in your computer needs instructions to do work. It gets this information from memory. So in practice, memory will hold the information, and the CPU will do something based on this information. As an analogy, you can think of the memory as a cookbook and the CPU as the chef. The chef will read the instructions out of the cookbook and execute those instructions. Ideally, memory would be fast, large, and cheap. This way you can have fast access to instructions, never run out of room for programs, and not have to spend all this money as well. Unfortunately, this is just not possible. Therefore, we build computers using different layers or hierarchies of memory. The memory hierarchy is just a model to explain how this memory is arranged. The faster, more expensive, and smaller memory will be at the top. The slower, least expensive, and slowest memory will be at the bottom. Now you may be wondering by now how and why this works. Shouldn't the larger and slower memory just make the system unimaginably slow? Well, not exactly. This works because of a concept known as memory locality. This means the CPU will tend to access the same parts of memory. There are two types of locality. Temporal locality describes how the recently executed instructions are likely to be executed again. Spatial locality describes how the CPU will like to access an instruction near a recently executed instruction. So let me reiterate and explain this a little better. The CPU will access local instructions more often than not. Temporal locality means the CPU will likely execute recent instructions. Think of this like a tab in your web browser. You open multiple tabs, switch between them. You are likely to reopen those tabs you have saved more than once. Spatial locality means the CPU will execute instructions near a recently executed instruction. This is like getting ready in the morning. Some people like to place items they will need for the day near each other, so you may leave your phone, keys, and wallet near each other, so they are there to grab in the morning. The CPU executes instructions very similarly. Computers like to keep data local, and the CPU will take advantage of this, accessing instructions that lie near each other. So what this means is that we don't need all the memory to be large and fast when we can access a small set of instructions quickly most of the time. This isn't always true, which is why we have slower, larger memory for storing less used instructions, but statistically most instructions needed are going to be closer to the CPU on average. So the memory hierarchy lets us have the advantages of speed, size, and lower cost by arranging memory this way. This is quite a profound thing, really. Getting back to the structure of the memory hierarchy, I will now explain its composition. At the top of the hierarchy, we have registers. These are the fastest, smallest, and most expensive form of memory. The amount of memory is quite small indeed. x86-64 instruction set architecture CPUs, for instance, only have 16 full-length general-purpose registers for storing data. This is quite small. Obviously, we won't be able to fit a program registers alone, so we must add on more memory. Going down the pyramid, next we have cache. Most modern desktop processors will have 3 levels of cache, known as L1, L2, and L3 cache respectively. L1 is the fastest, most expensive, and smallest, with memory becoming slower, cheaper, and larger as we go down to L3. L1 cache will usually be on the processor itself. L2 and L3 cache will most often be found on the processor chip. The cache will store instructions from main memory. If you take apart a computer, you will likely see sticks of RAM which make up your main memory. These RAM modules hold information about currently running programs which are paged in or retrieved from secondary memory. Main memory is slower than cache but much larger, usually multiple gigabytes in systems as of now. The last part of this pyramid is secondary storage. This is where you can save programs even if the computer is turned off. In most modern computers, this will be your hard drive or SSD. This part of memory can be a terabyte or larger. This is where you can keep games, programs, movies, and other media persistently, and the computer will load in what you need. I am going to talk about this final part because it's becoming more relevant today. Not all memory has to be on the same machine. Local remote storage has been around for a while, but more recently, cloud storage is growing. This forms the remote secondary storage part of this pyramid. Say, for instance, you have a computer with a small hard drive or SSD. You can use a service like Google Drive to keep most of your documents in remote secondary storage, or in the cloud. You can download and upload media using it when needed, and this lets you keep more data than you could fit on your own machine. Classical discussion memory hierarchy may omit this part of the pyramid, but I thought it was important to talk about anyways. So to sum up, memory is arranged in a hierarchy. Faster, smaller, and more expensive memory is at the top, and slower, larger, and cheaper memory is at the bottom. This arrangement works because of the memory locality allowing systems to operate effectively. Thank you for watching, and have a great day.